Okay, let us focus now on this one. It says the diagram below shows a fixed pulley carrying a string with mass 5 at one end attached and light. Whenever you hear a light pulley, it means that the weight of that pulley is going to be negligible, or the mass, so we take it to be 0. So this is our A. Okay. Pulley attached to the other end. Another string passes over a pulley B, a pulley A, and carries mass 2 kg and 1 kg at the other end. So that this one is carrying another string. So we have 2 strings, the first one and then also the second one, which is passing over this pulley. This one which is passing over it has this, and then this one which is passing over this pulley, it has this 2 kg particles. Okay, so now from there, they ask, as you see there, they're asking us to find the acceleration in pulley A, then the acceleration in 5, 1, and 2, then the acceleration in both spins. So here the idea is very easy. You have to focus on the direction of the acceleration. Now you see that this weight is 5, this one is going to be 2. So because this one, you see that this one is going to be, we say because the weight of this one, the mass of this is negligible because it's light, so it consider the mass to be 0. This pulley, so meaning now this and this is 3 and this is 5. So meaning this one is going to be having a greater weight, so it's going to pull it directly. So now the acceleration here, we are going to take it in this direction. It's going to be a1 because this is weighter than these two combined. Okay, and then meaning that also now this pulley will move in that direction. It's going to be moved in that direction, a1. We always focus. Now, this direction, this acceleration here, relative to these two, is what is going to help us get the overall acceleration here and the overall acceleration there. Okay. Now remember, if you consider now this only this, if you ignore this and you consider only this pulley, because this is weighter than this, it means that you are going to be having an acceleration in this direction like this, and then this one is going to be moving up like this because this one is going to be pulley. Based on this pulley, so if we call this one acceleration as the second acceleration, and this one is going to be pulling it like this. But remember, this one is being considered for only this. Now, the overall acceleration for this particle here is going to be, the overall acceleration is going to be, for this particle, is going to be, remember, for it, this one is going to be moving downwards. Here, this one is going to be, remember, the overall pull is moving upwards, yes, this one is moving downwards. So here, the acceleration for this one is going to be moving downwards like this, with an acceleration of, you see, it's opposing the overall acceleration of this pulley which is carrying them. So we get A2 now minus A1. Because here, now the acceleration is this side, here this one is going down. Yet this overall acceleration is going to be now, the overall acceleration for this is going to be now, you see it's going this way based on the direction, the acceleration of this pulley which is carrying them. So that it's going upwards, so mean that even this one is going upwards, so this will be now A1 plus A2. So this one is going to be A2 plus A1. What will be the direction? Is that for it is going to be moving upwards like this. We base on this acceleration to get the overall acceleration of these two. Okay? The overall. So this one is the overall acceleration. Overall or relative acceleration of this. So that's it. When you know that, the rest are very easy. This one, the moment you see you have a second, first consider the acceleration of this pulley. When you are ignoring this, if this one is moving, this one is not moving like this, then this one will be pulled like this. But if you want to get the overall, because it's one system, you consider the pulley, the acceleration of this pulley carrying these two. So this one is going up and this one is going up. So this we shall add. You see this one is going up and this one is going down. We get this, the acceleration of this in this system minus the acceleration of the pulley. So after explaining that, I think the rest are okay. So here the weight is going to be G, here it's going to be G, here the weight is going to be 5 times G, and the rest is just to resolve. To get the result. And so we consider the 5 kg. The 5 kg, remember the direction is going to be in this order. A1. So remember our resultant force is equal to MA. Our resultant in this direction is being brought. Okay, let us put in our tension. So this one is going to be tension. Let us call tension 1. If this spring, this is the same spring. this one and this. Then this is another string which is having a different tension, which I'm going to call T2. This is T2. Okay, now from there, we have this now. So this one is going to be acting downwards. We base on the acceleration of that particle. So this acceleration of this particle is going to be in this order. So the force that is taking it there, you have first of all 5D. Then minus, there is the force which is opposite, which is T1. Equaling to the mass, which is 5, times the acceleration, which is A1. And we call this equation 1. When we come now to Pulley A, you see that this direction of this pulley is in this order. So RFR equaling to MA. R is out, and what is pushing it up? You start what is pulling it up is T1. So we have now T1 minus, there are two forces which are opposing. First is T2, then minus T2 equaling to, because this is light, the weight is negligible. Because it's light, pulley. So meaning the mass is 0. It has an acceleration, but the mass is 0. So this would be, so from there, our T1 is going to be T2. I call this equation 2. Then I come now to a 1 kilogram mass. 1 kilogram, you see, its acceleration is upwards, so its acceleration is going to be in this order, which is A2 plus A1. So acting, considering the F, R equaling to MA, our resultant force. You see it's moving up, so it's going to be T2 minus the force opposite, which is B, equaling to M, which is 1, times the acceleration, which is A2 plus A1. As simple as that. So I call this equation 3. And I come now to 2 kilogram mass. You see now, its acceleration for it is downwards. The acceleration gives you everything you need. So A2 minus A1. So from RFR equaling to MA. So now we are going to be having the resultant. Pulling it down is going to be 2G minus T2 equaling to the mass 2 into the acceleration A2 minus A1, which when we simplify, we get 2D minus 2T equaling to 2A2 minus 2A1, and equal this one equation 4. The rest is just solving. How you will solve this? Idea is easy. I'm going to put this in this, that I have T1, I have T2 and A1, then I use this and solve, and I simplify life. So now, if we put 2 in 1, put 2 in 1. So if I put that 2 in 1, okay, or we can get here and then we solve and we remove A to N. What is that with? So if we put it in 1, we are going to be having 5D minus 2T2 equaling to 5A1. So that equation now is going to give us 5D minus 2T2 equaling 5A1, and we call this one equation 5. Okay, then from here I want to eliminate I have A1, so I want to eliminate A2. What am I going to do? I'm going to say multiply here by 2, then subtract. So we are going to say equation 4 minus 2 equation 3. So equation 4 is going to be here, which is 2b minus 1. The subtract of 2 in equation 3. Multiply here by 2, we shall get, okay, I want to start with b. I have minus 2b plus 2t2 equaling to 2a2 plus 2a1. Then we subtract this. When I subtract, this will give me 4g minus 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 3t2. This this minus, equaling to this minus this vanishes, this minus this to give us negative 4a1. I call this equation 6. Now it's that we can easily solve this, and it is how you're going to do that. We are going to say, now so let us eliminate T2. So you see this is 2 and this is 3. So we are going to say, what are you going to say? We are going to say, we multiply this 3 here and multiply this 2 here. So we say 3 in equation 5, then minus this 2 in the equation, 2, we multiply it 2 in equation 6, because they are in the same sign, so we need to subtract. So 3 in here, we have 15d. Okay, we have 15d minus 3 here, 62, equaling 3 here, 15a1. Okay, then here we multiply 2 in equation 6. So this will give us 8d minus 62 equaling to negative 8a1. Then we subtract. We subtract this minus this, it will give us 7. Yeah, this minus will give us a 7. So we have 7d equaling to this minus will give us 23a1. Okay, when you subtract here, this minus, so it gives us our a1 is going to be 7d over 23. And that would be, because we can easily get a d. And we can use the put for the d. Then after getting that, we come and we get our T2. Which one is easier to get? T2. Okay. From here, I wonder what which is okay. The problem we have the 2 is not there, and I have nothing to do. I have, okay. From here, let me first get T1. Because if I have T1, I can get T2. So from here, let me get T1 because I have A1. So from 1, you see that now my T1 is going to be equal to, I take this side, I take this side. This will be 5d minus 5a1. So here my T1 is going to be 5d, then minus this 5 into 7d over 23. So my T1 will get your calculator. You see that this is going to be 23 times 5, then minus, this is going to be 35. So 80, so we have 80 d over 23. And then you see, if I have T1, I can get my T2, because T2 is a half of that. So notice that from 2, so that my T2 is a half of T1. So my T2, which will be a half of 80 over 23d, which will be, so my T2 is going to be 40d over 23. You see, you can easily get these ones. Okay, so if I have T2, I can get a 2. Yep. Okay, where are we? Which equation can we use to get a 2 with ease? Okay, I think we can use this. So allow me to use this part. Okay, allow me to use this part. So I'm saying from now, from this equation 3, my F2 will be, when I take this side, it's going to be T2 minus D minus A1. So my T2, first of all, is going to be 40D over 23 minus D minus A1, which is 7D over 23. Not started to 23, which is going to be, so my A2, let us see, this is going to be 33 minus 23. That will give me 10 over 23 gig. So you get this minus this because the same is same. So 40 minus 733. Then you get the same pi here 23 minus 33 will be 10 gig over that. So that will be our A2. So now I have everything. I think the rest people can complete. So now don't forget to substitute the gig because the gig is 9.8. So at Pulley A, so this is my part A, number 1. Acceleration at A. Sorry. Okay, so here my acceleration at this part A at the pulley. So number 1, pulley A. So my acceleration there, we said that at pulley A, acceleration is going to be A1. It's going to be A1, which will be, where is our A1? It's going to be 7 over 33. Then G, which will be 7 into 9.8 over 23. And so our A1, you can every put the acceleration there. And then you give it in meters per second squared. Then when you come to number 2, if I come to the 5 kilogram mass, 5 kilogram, my acceleration there, we say it's going to be A1. But you see this A1 is in the other direction. So this one is, you see, upwards, this one is downwards. So A1, which is going to be the same as 7 over 23. But now we indicate this is going to be downwards. Downwards. So this one will indicate upwards. Upwards. That is the difference. Okay, so when you come to 1 kilogram, okay, 1 kg, our acceleration was 1 kg, it was A1 or A2 plus A2. Our A1, my A1 is 7 g over 23 plus A2 10 over 23 g, which will be giving us 17 over 23 g. You can every substitute in this g. So our acceleration will be 17 into 9.8 over 23 equaling to that in meters per second squared. You give them for the small places if they give you the acceleration. Then what is 2 kilogram particle? So at the 2 kilogram, acceleration was A2 minus A1. What is our A2? Our A2 is 10 g over 23 minus A1, which is 7 over 23 g, which will give us 3 g over 23, which we can every give. You put the g, then you give it to meters per second. Then the tension is the same thing. Our T2, this is now part B, our T2 will be 40 over 23 g, okay, g, which will be 40 into 9.8 over 23. Then these are in newtons. Then T1 is going to be, it's here, 80 over 23 g, which will be 80 into 9.8 over 23 newtons. You give your answer to Newton for decimal places. So that's how we handle. The idea is, I think you see that it depends on the direction of these two things. So that's it. I wish you well.